funded by the government on corruption. It has been accepted with the deliberation of the board of administration of the agency, and it has been approved by Professor Rubia, which is the president of ENEA. So it's a little thing, it's a small program, but it could be a start. And now I would like to ask, as the last program speaker, to Professor Takahashi to say a few words.
Well, first I should like to say grazie 100 times to all the members of the local organization committee who have realized this beautiful conference, however, with still controversial topics. Now, I want to show some kind of review summary from the Far East country, one Far East country nation. I think first of all, the key facts, I'd say we are about to fix two things. First, so to say, the nuclear ash, helium-4, I mean, in correlation with excess heat, but without neutron emission, is almost confirmed. We have a very nice contribution in this conference by Dr. Markov, Professor Arata, and followed by Sobe, Lenino, and so on. And probably this phenomenon would be a kind of, so to say, coherent fusion, not the known usual D plus D fusion. The second thing is I think nearly confirmed is the so-called transmutation. There seems something strange exists, as reported by Dr. Wana, Iwamura, Mizuno, and Professor Mari, and Karabu, and so on. Sorry. Probably we can have a kind of strange thing like photofission or something else. Anyway, there are something strange. So we need a variety of strange explanations, models, to check and to establish in some way. This is, I think, the key facts we have obtained in this conference. And the second thing I can say, many things are in progress. First of all, we need now really a kind of new theory, so to say, coherent fusion theories, as proposed in the conference by Professor Hegelstein, Chav, and Lerici, Violante, and Oda, and so on. Secondly, we have many reports about the excess heat measurement and how to stimulate excess heat effect. However, my Japanese colleague, electrochemist Professor Oda, says the evidence reported in this conference are not enough in the sense of chemistry. However, I point out two things. One is the somewhat large excess heat phenomenon and associating some nuclear-like products by discharge type electrolysis, as reported by Dr. Mizuno Hokkaido University, and which shows the somewhat big excessive like 300%, he claimed. And the second thing is very controversial and also very important was the NHE long as reported by Dr. Myers and Professor Fleischmann. Unfortunately, I have no responsibility to answer this big question. Probably some person existing in Tokyo may answer later on. And the third thing is we are still looking for the nuclear, say, products like neutron and charged particles and so on, as reported by Professor Kasagi and Dr. Lipson, Kubota, Isobe, and Wan, and so on. And fourthly, I should like to say something about the material problem, especially the deuterium loading to attain the high loading. Probably some special condition using thin wire or surface modified material based on palladium, nickel, titanium, and so on. We have many records. However, I should like to point out only one thing: the so-called Ken Aharonov and then put the repellent effect would be important, and as reported by Dr. Cerami and Dr. Lerici. And I think this conference was a kind of memorial conference to our reminiscent Giuliano Preparata. So far, I should like to say this thing. And lastly, I'd like to say a few words. Probably the ICCF, we're not sure, ICCF survives in the 21st century, at least until 2002 in Beijing. However, we'll be getting in the new phase, so-called second phase, as Professor Martin Fleischmann pointed out in his talk. However, I have to say something pessimistic, because this ICCF-8 conference, we had about 140 registration, but real participants will be 120 or so. So this number is now decreasing. We have decreasing trend. So I guess we need to extend our community somehow. So probably, in my opinion, a kind of, say, philosophy, science only is very important, is not enough. Probably we need to attract, for example, industry people, as Professor Myron pointed out, and also we have to attract the other scientists from other fields, of course. And of course, probably most important point is we have to attract the very active young people for the future. This is very important. And also, probably, we shall not reject the crazy ideas. Probably that can decorate our around somewhere. And finally, as Dr. Beverian proposed, probably we need our common media in the internet. We need some kind of electronic journal. Okay, this is my short comments.
On the top, on the right.
Okay, we finished the first part of our conclusion session, and now I would like to ask anybody who wants to come and give a little speech. I would recommend not to stay more than 5 minutes, possibly better less. So add and
well, I would like to make some comments, some of which are absolutely obvious and will reiterate what has already been said, and some of which will no doubt lead to great controversy and conflict. It's perfectly obvious that we have to have materials that are reproducible and we have to have a theory. These two are interconnected. You cannot create a theory without reproducibility because you can't measure the parameters necessary to support the theory. And likewise, you cannot get reproducibility without a good theory. So we're between a rock and a hard place on that one. But because of historical reasons, palladium has been chosen as the material on which this phenomenon is based to a large extent. Unfortunately, palladium is one of the most irreproducible materials known to man. This is not just in the cold fusion field, in every other application it's very difficult to duplicate its properties. The result is we've been handicapped from the beginning, and I would suggest that palladium was a very poor choice. We now know that a number of other metals produce the effect. Platinum, gold, titanium, and nickel. And some of these appear to be much more reproducible. Now this creates a problem. We have a great deal of information about palladium, and there are many theoreticians present who have devoted most of their professional life in cold fusion to understanding the phenomena in palladium. I would suggest, and this is where some steam will start to rise in certain quarters, that any theory that is based upon palladium and palladium alone has got to be wrong. We have to get theory that is applicable to these other materials that are known to produce excess energy. So I would really encourage you, those of you who have concentrated on palladium, to broaden your horizon and start considering other possibilities. Now, I've been asked by some people who don't want to bother to get up here and talk to point out some things. There's a website, Alternate Energy Institute. It is online, and it has a section on cold fusion, to which the originators of this website would like many people to contribute, and also would like input, would like it to be a source of information for the field. So I would invite you to visit that website and make your comments, and you will see some information about this conference on that website after Don gets back to work. And the other issue, of course, that we need to emphasize is the need to trade samples. I mean, it's absolutely essential that laboratories collaborate, cooperate, and share information, even though that may jeopardize potential commercial, proprietary considerations, and it might in fact result in your not making $1 million, but maybe only $500 million. I mean, you might lose in the process some money, but you will gain in the long run. And I would suggest one of the problems I see happening is that once somebody discovers how to make it work, they suddenly shut up and they don't share anything. And that's, that right away is self-defeating, and it's the information that they discovered to allow it to work is then denied to everybody else. And that stifles the field. We've got to quit doing that and start sharing, even though it might result in loss of intellectual property. Okay, thank you very much.
Excuse me, what is the website address?
I will give, Don will give you a card that has that on it. I don't know if reading it will do you any good. It's www.altenergy.org, and I will read it. Spell out ALTENERGY.org.
Slide.
troppo il più.
No, that's okay. That's it. I just wanted to emphasize the importance of exchanging materials.
He's right there. I know.
Yes, I want to say something. The first thing is that just the parent was a member in 1989. I remember that at that time I was really stressing the fact that Aladdin doesn't die as a catalyst, and that the reaction found at the time at Mallove was just a small part of a more large field, which now is called low-energy nuclear reactions. And again, and also in this decision, I want to remember one thing. This term, low-energy nuclear reaction, is the exact translation of a French term named in such a way by Louis Kerbrand in the 60s. So it's not a new thing. Finally, we are arriving to the conclusion that even the word cold fusion is not exactly in the sense that you have seen, for example, from Buku, that also cold fission exists. That is even more important. For example, can be useful for industrial purposes like electronic nuclear waste and so on. So yeah, you have attached a completely not new, but new for this century field, which has a very wide possibility of applications, which you are just starting to discover now. Obviously, the fact that people could not believe or have been contact with fusion in a certain sense, it has reason, because we are not in front of cold fusion, but a more general fact, which is low energy reaction, which includes cold fusion and cold fission. You have seen that you can make cold fusion also from the smaller heavy atoms, but also cold fission. This is a general field which is known already since at least in this century, from my first year, because I remember that the first hints claiming scientific results in this field were made by Kerbrand in the 60s, by Jawa and other people in Japan. For example, the biological mutation, which you have seen in a paper coming from Russia. You could see tens of these papers years ago in the 60s from Japan, for example, and also from France, from Kerbrand. So I think that the term cold fusion, international cold fusion, is not appropriate. We are at least to add, in my opinion, the term cold fusion and cold fission. And although both these items are included in the term low energy reactions, which should be a more appropriate term. As a matter of fact, it's to another thing that Dr. Takagi underlined, that if this study remains confined to the idea of the cold fusion in the frightening point sense, they will die very, very soon. Because the field, as it is more general, interests wider in fields like, for example, biological mutations, geological effects, and so on. These fields you are to investigate has already been investigated years ago, then has been forgotten. Now it's time to look from a wider point of view all these problems. So I repeat again that leaving this conference to the term cold fusion is, in my opinion, inappropriate. And we are in front of something much more large and wide that we are just, I hope, near to discover.
Just a brief comment. The name confusion is a historical name because when it was proposed by Fleischmann and Pons in 1989, it was compared with the traditional thermonuclear fusion, which was very hot, hundreds of millions of degrees. I agree that there are many phenomena which are not only fusion, and so it would be sensible to change the name, but this is an historical name, and fission is called, also the traditional fission is called temperature.
Franco. Non guardare, non guardi.
Ah, segnalo poi la
First of all, I'm absolutely delighted to be here, as I always am. I think the only conference ICCF I missed was Como, and I attribute that to MIT. But I do want to comment about several important comments that Dr. Scaramuzzi made, and Dr. Bavarian, and Dr. Takahashi. Okay, I very much agree with Jean-Paul. Or is it Jean-Pierre? I forget. Oh, Jean-Paul. Okay, sorry. Yes, the field has a Cinderella complex. There's absolutely no doubt about this. We must have, as I said at ICCF-8, when we had more attendees, by the way, I am impressed, by the way, with the increase in information presented at this conference. The data is much better, even in a smaller group. But we must have demonstration units, if you want to call them that. Call them transfer of cells between laboratories. But my own perspective, as a person involved in the media, in the science, in the commercialization, the single missing ingredient is a completely reproducible cell, or even statistically highly reproducible cell, that is commercially available or is free. We must have that. And what I believe this will lead to, following what Professor Takahashi said, is enormous industrial interest. You can bring an industry into one laboratory and show them a working experiment, or show them the peer-reviewed papers, but that does not cut the mustard. It must be done wholesale. It cannot be done retail. One company, for example, SETI, which made a very high profile and had absolutely real results, okay, is now sort of moribund. Another company may be starting up and so forth, or is starting up. Fine, good. But we must have, as Jed Rothwell always says, and I think he's absolutely correct, we must have tens of thousands, hundreds of thousands of people working on this. And there's only one way to do it. It's not the peer-reviewed literature. First of all, we can't get into Nature, we can't get into Science, we can barely get into some of the other peer-reviewed. We must have demonstration cells. We do not want to be Cinderellas forever. So that is, I respect Dr. Scaramuzzi's point of view very much. I understand it, that science, he says science should be first. But I believe that since we have very little funding for science, I think the way to excite more funding for science is to have a parallel course with the industrial applications, the whiff of money, so to speak. And if I may say, there's a possibility that this is not just a commercial break or anything, we may show this film after, if the technicians are willing, after the lunch. And finally, I feel a bit sorry that many of you may not know that we have a famous author here, Charles Baudet over there. It came to my attention that even though this book of his, which he just finished, a marvelous book on excess heat and cold fusion, it is available, and I have the money interest is not the point. I have boxes, and I don't want to have to take them back to the United States. So if you'll kindly purchase these books, he would be very happy, and the word will spread that way too. Thank you.
I agree that having parallel efforts is very important. I need money. Dr. Andreani.
Thank you for giving me the floor. I was calling your attention because I had the impression that you were not going on the end of the room. But I'm in a rather unique position, I think, here because perhaps as you know, I am responsible for a rather large laboratory in Italy, in Enea, working on, especially on hot fusion, of course. And I'm even going to move to Garkin next month to work specifically on ITER, to try to get ITER through and to get ITER built. Because we feel that, apart from cold fusion, we have to progress in the field of energy, and one way that we have to do, that we can, which we can go, is fusion, and initially probably in its hot form.
But since the beginning, since the first experiments which were done, I remember in Frascati back in, I think, 1989, we were very much favorable, and EA in general, and myself in particular, on the fact that we had to look to this possibility in a very rigorously scientific way. And this is the way we have been progressing. And I must say that I have heard here, I was only here today, I have heard about the Cinderella complex, problems with getting cold fusion well introduced in the scientific community. Well, I have to say that among my colleagues working on hot fusion, effectively cold fusion is not very popular, and very often when I go around I say that in Frascati we are working on cold fusion, I don't receive a very enthusiastic reception. They look at me as saying, these poor people in effect, but and then I try to explain to them, for example, one of the most common objections is that no nuclear fusion can occur without neutrons, and then immediately I can answer, remember in fusion we have proton-boron reactions where no neutrons are produced, and they are certainly nuclear reactions. Then if you accept my opinion, I think that the way in which we are conducting these activities in Frascati, I think is the correct one. What I would recommend to you, and very humbly, because I'm not a specialist of cold fusion, is that we should progress with extreme and rigorous scientific ways. That is the way you could overcome the Cinderella complex. The Cinderella complex cannot be overcome simply by writing articles, but by doing experiments which are absolutely convincing. I've heard here, I think Professor Arata or Takashi, who was speaking before, saying that the production of excess of helium-4 and excess heat was almost confirmed. That on the transmutations nearly confirmed. If I may give a suggestion, and this is what I tell my young colleagues working on this, we have to be absolutely convincing. We have to produce experiments in which the measurements are absolutely right, that we can reproduce. And one thing which seems to me sometimes missing in this is the fact that we should be able to make experiments in one laboratory, repeat them in another laboratory. While perhaps for reasons of competition, I see a lot of attempts to make experiments. I think that perhaps, maybe this is already occurring, I don't know exactly, but if we could do experiments in one laboratory, do experiments in another laboratory, which are perfectly comparable, this would help a lot in establishing the soundness of our efforts. So, the only thing that I can say, I'm impressed by the strong will of the people working on this field. You know very well that also in hot fusion we have to fight our way, because politicians, especially now in this country and also in other countries in Europe, are not so much in favor. We have strong opponents for reasons which to me seem quite debatable, but anyway, it is so. And here I see people who are really convinced of what they are doing. And this is, I think, the best basis to go ahead. So I can only say that I wish you good success in your work, but remember, you have a very strong opposition. And you have to convince the people. And the only way to convince the people is to do experiments which are absolutely out of doubt. Thank you.
Thanks to Andreani. Just a couple of comments. One is about the reproducibility. I appreciate the position of Professor Takashi. I would be a little more positive. Not for all experiments, but there are experiments presently which are totally reproducible. And I think that so this is already something that will be obtained.
Which ones?
Second, I agree with Dr. Adriani about the importance of exchanging, experiment, collaborating, making checks, reciprocal checks. And, but I don't think that this did not happen because of people being afraid to exchange information, but rather because the resources dedicated to this research have been always very little. And in order to make also this, you need a little more largeness. Okay. Any questions? Anyone wants to take the floor? If nobody asked to come. Now you. Yes. Professor,
John Fisher.
he asked me to be able to present something scientific. I told him 5 minutes.
Right.
Huh?
I will not take 5 minutes either.
Okay, wonderful.
I'd like to say a little something about the role of theory at this stage of our common endeavor. There are a lot of theories around. There ought to be a lot of theories around. And there's a lot of arguing about this theory being right, that theory being right, this theory being wrong, that theory being wrong. But at this stage, it may not be necessary that a theory be correct if it motivates an experiment that otherwise wouldn't have been undertaken. After all, Columbus thought he was going to India. In our field, we have an outstanding example of a motivating theory. Fleischmann and Pons had a theory, an idea, that if they would crowd deuterium into palladium by means of electrolysis, they might be able to initiate room temperature nuclear fusion. And they had the energy and the courage to try it. And they had the astounding experience of seeing it work. So their theory had served a very valuable purpose. Now, in the fullness of time, that theory may prove to be correct, or incorrect, or partially correct. But in a sense, that's irrelevant. It served its purpose by motivating their experiment. I sometimes wonder that without Fleischmann and Pons and their motivation, how long it might have been before somebody else would do an experiment like that and would have the wit to see that what they had done was significant, and they'd have the courage to publish it and face the consequences. Would it be a decade? Perhaps a century? Perhaps never. So here we see how theory at our stage of the business can be of value. Why I think it's important to have a lot of theories. I argue with people about their theories. I think they're mostly all wrong. I think they probably are mostly all wrong, but they are mostly all useful at the present time. So it's tough being a theoretician in this milieu because there's so many theories. Nobody believes what we are working on. Referees are down on us. Our papers are often rejected. But we press on, and we should press on.
Thank you. There is a speech, double chance. Well, first, can I push something there? No. First, I want to say we've already had experience with transferring technology from one laboratory to another. In the example of the Raleigh work with the DS cathode being transferred to SRI. And I think that has had very good effects. And it has led to more quantitative observations of helium-4 and the new results that were presented by McCoubrey on helium-3, which I think is a very, very strong signature for
the nuclear process. And the other thing, I just want to say, it seems to me that from the theoretical point of view, something that really begins to interest me more and more really comes out of the experimental programs, comments on the people who are doing electrolytic work with deuterium, namely the role of fluxing, of moving deuterons in and out or through materials, which of course is a theme also of your program and that Professor Fleischmann has been talking about for years, which doesn't always enter very directly into our theories, but which experimenters keep emphasizing very importantly that this is not a steady state equilibrium phenomenon, at least they don't feel so in their experiments. And I don't know what to say, except that I think that maybe those people who are working in theory need to take that increasingly into account. And that's all.
Yep. Any other? Yeah?
I'd like to make a little comment regarding biological transmutations, because I didn't want to talk about it at this conference, because now the conference is over. Well, 15 minutes I could talk about it. Not for 15 minutes. But just for a minute. I've done experiments with biological transmutations, with bacteria and with seeds, sprouted seeds, and we've seen interesting things. I've been very interested by the poster that was yesterday showing the production of iron and the production of manganese. We have looked at production of calcium, small changes, a few percent. We are continuing in that direction. We had a meeting, the first international workshop on biological transmutation was organized on May 1st. It's a day off in Europe. May 1st, it's Labor Day in Europe. And anyway, these people went in Geneva for a meeting there. There were people from Italy, Switzerland, and France. We were 16 altogether. And we started to work on that subject internationally. So I hope more people would join us in that group. I think this is very important because that has been discovered in 1799 by Vauquelin, which is a very famous scientist, since one of the streets in Paris has his name, that's where two Nobel Prize winners are located, actually, by Vauquelin Street, anyway. I think this broadens the field of cold fusion. I didn't want to mix it with cold fusion because it's already confusing enough. And very controversial, more controversial than cold fusion. We don't have any funding for that, obviously. It's so hard to get funding for cold fusion. Forget about biological transmutation. So we started a non-profit organization for that, and looking for members, things like that. So we are opening a website for that too. So I think this is very, very important. I think it's 21st century will be a very exciting century, more than 20th century. Okay, thank you.
No more questions. I would like to ask Professor Li Xinzong to come up here. And I think that most of you were present last evening when I made the announcement that the International Advisory Committee has decided that the next conference, ICCF-9, will be held in China, Beijing, and Professor Li is the design chairman. And so I now give to him the baton.
Thank you. I spoke yesterday, so I don't think I will say more about this. But I have to say something I thought last night. 10 years ago, when I was a visiting scientist at the Institute for Fusion Study at Austin, United States, I received a telephone call from Professor Scaramuzzi. He asked me if I would like to be a member of International Advisory Committee. I asked him what this means. What should I do to be a member? I could not remember what he answered because I didn't understand very well. Gradually, I understood. This means someday I will be on the hot plate. Now I say a little bit about last night. I thought, what will be the theme for the ICCF-8? I believe it's coherence. I think the theme for ICCF-8 is coherence in three senses. The coherence in solid, the coherence in research, in R&D, and coherence between cold fusion and hot fusion. In my mind, the most important question remains the reproducibility. If we can solve the coherence problem theoretically and experimentally, we may solve the reproducibility problem. The second, we have to pay attention on research and development. I believe New Hydrogen Energy Institute made a mistake. They put too much emphasis on the development and ignore the research too much. But in the same time, we should try to consider the possibility to build a heater just based on heat after death. If there is any possibility to work on this, I think that's a good idea. This morning I talked to the German journalist. I say the Germans should jump into cold fusion, and a heater with heat after death may be the good way to go. The third, we should have a good coherence between the cold fusion and hot fusion. I believe eventually we will merge together because we are working for the same goal, the green fusion energy without strong nuclear radiation. So if we work together for these three coherence, if we succeed, we will make one step toward this goal. Thank you.